guys. Today we're looking at lesson 8 in our algebra, Saxon Algebra 2, lesson 8 here. So today we're talking about polynomials and graphing linear equations, and then which we've already done before. And then we're going to move into an easier method, which we again learned in the last book, or Algebra 1, but it's the intercept slope method. Make things a little bit easier. And once you grasp the initial graphing, then you can move into that easier version, maybe save a little time, a little effort, make things just a little bit quicker, which is always helpful when you're doing your math. So we're going to talk really quick about polynomials, just to give us a brief description. So that way when we read a book and it's talking about polynomials, maybe some other terms we're not familiar with, binomials or trinomials or even monomials, we know what they're talking about, and so we won't be confused there. So let's look at a few things. We have a lot of sets of numbers here, and I kind of maybe divided some commas so you can see what we're looking at here. But we're going to see a -4, a 1/2, a 2x, an x plus 2, an x to the 4th plus 2x, even a longer one here, a 2x squared plus 3x plus 2, and then maybe something just a little bit different here, a 2x plus 3y equals 6. And so we can obviously look at all of these and decide that these are completely different. They are not the same thing, but you would be right if we said that. But we would also be right in saying that these are, and hopefully you can see the edge here, but these are all called polynomials. Polynomials, and what is a polynomial? It's just a simple expression that's used to designate maybe a set of numbers, a solution, maybe some letters that we would see that, some variables with those. But we could also break this down into a few subcategories, not just polynomials. We could break it down this way. We could call this a monomial. Mono meaning one, being one term there, just one term. We could also break them down into binomials. And we could see the 2 there for binomials. We can even go a little further and say trinomials. We can see that right here. I'm making that a trinomial. And this one here, you'd say, well, but Chad, that's also a trinomial, and you'd be right, but the difference is it's not just an expression. It's not just a solution, but a trinomial with an equal sign, we're going to call a trinomial equation. So that's a trinomial equation. But just so we're not confused, when you see the word polynomial, that could be any here. Of course, poly, our prefix, really has the meaning of many. So it could be many. 3 could be many, 2 could be many. And even in a general sense, you're going to hear or see the book sometimes say polynomials, and it even occasionally have just one term, one expression there, and they'll group it in polynomials. But just so you understand where the word polynomial is coming from, it can be broken down with mono, bi, tri, or even a trinomial equation. So we don't want you to get confused with those. Not a whole lot to deal with now with those, but in looking at this particular trinomial equation, which is going to be our springboard into what we're going to talk about with linear graphs. Our book tells us that the graph of a first-degree polynomial equation in 2 unknowns is a straight line. Now this is a first-degree polynomial equation. How do we know it's a first-degree polynomial equation? Well, we can see we have a 2x plus 3y equals 6, and it has to do really with our variables being a first-degree variable, which we'll talk a little bit more about later. Maybe we'll get into some more work with that, but easy enough to see that our variables here are just first degree. Our powers are just a 1, they're a first degree polynomial equation. And we're going to move over far side of the board now when we're talking about 8b. So we jumped just right off what a polynomial was, what a polynomial equation was, a first degree polynomial equation. If we have two unknowns, an x and a y, we can graph that onto a graph, and hopefully you can see this small graph down here. We don't have anything on it yet, but we can graph onto a graph in a straight line. In other words, what we're saying is, I'll just kind of use this right here, this point, whatever graph that may be is going to be a straight line. It could be down, it could be across, it could be up. If there's two unknown variables there, then it's going to be a straight line. And so we're going to get to work on how do we figure out from this, which is the same equation we had down here, 2x plus 3y equals 6. We're going to use that in our graphing. How do we figure out how that equates or turns into a straight line on this graph? Well, I'm glad you asked, because we can certainly do it. But before we jump into this equation, before we start plugging in numbers and figuring out what in the world we're doing, we have to go back, think back to Algebra 1, and remember that our graphing linear equations had maybe a few different steps. And if you look in your book, it gives you 5 basic steps. I'm reading them just as the book has it. It says, number 1, solve the equation for y. And number 2, make the table and select convenient values of x. We already have our table drawn for you. Number 3, use these values of x in the equation to find the matching values of y, which we're going to do that. And then we're going to complete the table. That's number 4. And then 5, we're going to graph the ordered pairs that we're given. Okay, so step number 1 tells us that we have to solve the equation for y. Now, if you remember, we talked about this the other day, but that means y has got to be on one side by itself. Everything else has to be on the other side. So we'll go ahead and look at our equation here and do that. Now remember, just a quick and easy here, we're going to take this 2x over to the other side. Remember we said change sides, change signs. And so I'm going to drop it down just here and say 3y now equals negative 2x plus 6. Okay, so we're off to a good start. We got y's on one side by itself, everything else on the other. But we're still left with the problem. We have a 3 in front of that y. And that's not what it's asking us to do. It's asking us to solve for y, not for 3y. So we have to undo that 3 and that y. Inverse operations, if it's being multiplied to y, and it is, we're going to need to divide by 3 to undo that. But remember, when we divide by anything, not just by 3, but when we divide by anything, we have to divide everything by that same number. And so what happens is this 3 cancels, and we end up with y equals a negative 2/3 x plus 2, because this 3 goes into that 6 2 times. So now we have y equals negative 2/3 x plus 2, a basic equation, and that's something that we can work with. We can make this work for us very easily when it comes to this table. So step 1, we solve the equation for y. Step 2, we make a table and select convenient values for x. We made the table. Let's go ahead and select a convenient value for x. Now, whenever I'm teaching this, I'm telling students, if we're just learning this method, what's the first value for x you always choose? And inevitably, somebody will say 1 or 2 or 3 or 5 or 10 or one of those numbers. We're going to make it crazy easy on us. And the first value for x we're going to use is 0. And say, why would we use 0? Because we're going to come down here and we're going to say that y equals negative 2/3 times 0 plus 2, because we're just plugging 0 in for x. And what's anything times 0? Yeah, it's 0. And so if this whole thing is 0, 0 plus 2 makes y 2. And say, well, that's pretty easy. I agree, it is pretty easy. And so what are we going to do now? What number could we use now? And again, the answer typically I get is maybe the number 1. If 0 is easy, 1's got to be easy too. The problem that we run into with that is we have a fraction in our y. And if we make this x a 1, we have negative 2/3 times 1, which is negative 2/3 plus 2. And that means that our y is going to be a fraction as well. And we can do that, but it just makes things a little more difficult to work with. And so let's go ahead and say, instead of making this x a 1, let's make the x a 3. You say, why would you do that? You'll see here in just a second. I'm going to say y equals negative 2/3 times 3 plus 2. Now here's why I like to make that a 3. Whatever my bottom number, my denominator, my fraction is, if there is one in this case, and there is, I'm going to make this the same number. Here's why, because I can just cancel that. And now I have a simple linear equation again, a negative 2 now plus 2 equals 0. So by making x 3, I can work this out to make y 0. Now right here, we have enough points to make our line, because all you need to make a straight line is 2 points. So we've learned that in the past. However, we don't want to stop with that. You say, well, why is that? Because my figures may have been wrong on one of these equations. Now, in this case, I don't believe they are, but it may be, and it may happen to you. And so what we're going to do is we're going to go through one more. And so that way, if we're plotting our points and we get 2 points, the first 2 points there, and say, oh, that looks good. It's a straight line. We can just draw a straight line. But what if our third point ends up something like that? Well, that's not a straight line. We would be looking like this, and there's a problem there. And so then we can go back and check our figures and check our equations. And so we're always going to use 3 different points just to double check ourselves and make sure that we're working things right. So let's go ahead and use another one. What do you think the number is we should use for our x? We're going to plug in right there. Use 0. We've already used 3 because that took away the fraction and made it an easy equation across. What other number could we use? Maybe to get rid of that fraction. Hopefully you said 6. Let's put a 6 right there. So let's go ahead and work that out. Y equals a negative 2/3 times 6 plus 2. Maybe draw that right there. You say, well, how does that help us? Well, again, we can cancel out with our fraction. 3 goes into 3 one time, 3 goes into 6 2 times. That's kind of sloppy right there, and I'm sorry if it looks that way. But what it equals out to is y equals negative 2 times 2 plus 2. And so y is going to equal negative 2 times 2. Negative 2 times 2 is negative 4 plus 2. Negative 4 plus 2 is negative 2. All right. And so now we have our table. That was step number 2. Step number 3, we're going to use the values of x in the equation to find the matching values. Well, that was step number 2 and 3. Step number 4, we're going to complete the table, and then 5, we're going to graph those ordered pairs. Okay, so we have all of this step 2, 3, 4. We kind of did in kind of a mush right there. Maybe I should have done it a little more set out for you, but nonetheless, we got the table completed. But now we have our ordered pairs, 0 and 2. So our ordered pairs look like this: 0 and 2, 3 and 0. And 6 and negative 2. These are the ordered pairs that we can graph right here. And so remember, ordered pairs always look like this. Put it up here, x and then y, alphabetical order. That's easy to remember. And so 0 and 2. So remember, this is our x-axis, the horizontal. Our y is the vertical axis. Okay, so 0 on the x-axis, which is right here, and 2 on the y. I'm going to put that point right there. That's our first point. Look at our next ordered pair, 3 and 0. So 3 on the x-axis right here, 0 on the y. Well, it's right there. That's pretty good. And then we have 6 and negative 2. Well, I didn't go all the way out to 6, but I can kind of guesstimate and then go down to negative 2. And so notice I have my points here, and I don't have a straight edge to draw, so it's going to be a little wavy. But I'm going to draw my straight line, or what should be my straight line, right there. So I have point, point, point that should be in order, and you can kind of see how they would be in order. And if I had some graphing paper, we can make them exact in order. If I had a straight edge, we can make that line perfectly straight. But we do get a straight line with that. And so it works out well. Now, that is our simple graphing of linear equations. We've done that before. Now, if you turn the page, look at page 52, 8.c is going to give us another concept here. It's called the intercept slope method. the intercept slope method. And I want you to look at 8.2, and I want to see 2x plus 3y equals 6. Same equation we just worked out before. You say, well, why are we doing the same problem before? Because we're going to use a different method and make it a little quicker, make it a little easier for us. And using the intercept slope method, there is something we have to do with everything before we touch, I guess, or start to throw things on our graph. We have to, in our minds, solve for y. Now, with solving for y, intercept slope method, there was something we learned again in algebra, and that was the basic form of a line. Y equals mx plus b. Y equals mx plus b. And just so we understand, we know our y and our x are our two unknowns. Our two unknowns give us a straight line. We've already talked about that of a first degree polynomial equation. M, what is m? M is the slope. Now remember what the slope really boils down to? If you don't, what it boils down to is the rise over the run. Or in other words, how far up or down it goes compared to how far to the right it moves. Now it never moves to the left. Slopes can go down, slopes can go up, but they can never move to the left. We're always moving toward the right. So m is our slope, our rise over our run. B is what we call the y-intercept. And what do we mean by y-intercept? Y-intercept is wherever that line crosses the y-axis at. That's where it intercepts, that's where it crosses the y. So pretty easy to understand there. So it has to be in this form, which we eventually got it down here. Our book says step number 1, solve for y. That's what we're going to do with this. In other words, get y on one side by itself, everything else on the other. And so let's look at this again. Remember, take that 2x to the other side. Remember our simple little saying, change sides, change signs. And so we have 3y equals a negative 2x plus 6. Okay, so we recall, we've seen this before. Are we where we need to be here? No, not quite yet. Again, we have to solve for y, which means we have to get that 3 out from there. So inverse operations means we have to divide. And dividing by 3, we can get it to say y equals negative 2/3 x plus 2. Now again, look at this compared to what we wrote here. We saw the y equals, the slope, the m, is now a negative 2/3. We have our x plus 2, or the y-intercept. Now there's something very important that we need to see when we're talking about this number right here, or this monomial right here in the middle, that negative 2/3 x. The negative 2/3 x, or whatever number comes with the x right there before it's attached to the x, tells us what our slope is. And the sign of that number is very important as well. The sign tells us whether it's going to be up or positive, or down, negative. And so if the sign before the number is positive, that line is going to go up. If the sign before the number is negative, that line is going to go down. Now what sign is before the number here? Yeah, it's negative. And so that means our line is going to be going down, or sloping down. Okay, so what does that mean now? What do we do at this point? Well, once we got that understood, we go to the very last number and look at that positive 2. What is that positive 2? Well, it's in the B spot. Remember, it's the y-intercept. That's where that line crosses the y at. Well, so this is 1, 2. So it's going to cross the y-intercept, or it's going to y-intercept cross the y-axis at 2. You say, well, okay, so where do we go from there? Well, now we use our slope, or negative 2/3. Remember what the slope is? It's the rise over the run. It's a negative 2/3. Is it going up or down? Yeah, it's going down. And so, down, rise. Now, remember, don't get confused with the rise. Just because it's rise over run doesn't mean you always have to go up. That rise could mean the up or the down. Negative, we're going down. Rise over run, 2/3. So we're going to go down 2, 1, 2, and we're going to go over 3. 1, 2, 3. And we can do that again. We can say 1, 2, 1, 2, 3. And so we have 3 points there, if you can see that, in a straight line. I want you to see the graph that we did right here compared to the graph we did right here. Same graph, same equation, except for right here, we broke it down into a really quick 2 or 3 steps as opposed to making a table and having to go through a lot of different problems. Just by knowing what the equation means, just by knowing what the m is, the slope, just by knowing what b means, a y-intercept, makes it pretty easy. Let's look at another one there that's in our book, 8.3. Y equals negative 3x minus 3. Y equals negative 3x minus 3. This should be pretty simple for us, but we're going to look at it and see if we can tell what each one of these mean. Well, we know that we have an m, which is our slope, which is the rise over the run. We have our b, which is our y-intercept. And so what's the first thing we're going to look for? Yeah, we're going to look for negative 3, because that's where it crosses our y-axis at. This is our y-axis, this is our x. It's going to cross at negative 3. Now, I don't have these numbered, so we'll just have to look at this being our origin, our 0. We're going to go down negative 1, negative 2, negative 3. So it crosses the y-axis way down here. All right, so let's look back at our previous number, this one here, negative 3x. What is negative 3? It's our m, it's our slope, it's our rise over our run. You may say, Chad, there's a problem. It's not a fraction, so there's not a rise over a run. But there is. We know that any whole number, and in this case it's negative 3, any whole number can be written as a fraction by putting it over the number 1. So negative 3 really means negative 3 over 1. And so now we have our rise over our run. We have a negative 3 over 1. Excuse me. So what does that mean? Well, that means we can go down 3, 1, 2, 3, and then over 1. We can do that, but there's a slight problem. We're already at the bottom of our graph. So what do we do in this case? Not a problem. We know that's negative, so the slope is going down. So how do we work back up the slope? Well, we just go backwards. Instead of going down 3 over 1, let's go back 1 and up 3. 1, 2, 3. We'll go back 1 and up 3. 1, 2, 3. Now again, these aren't going to be exactly straight because I don't have my graph exactly straight. But this would be how it would look. And you can look in your book on page 54 and see that it looks very, very similar to this. So our y equals negative 3x minus 3 using the slope-intercept form can be quickly done. And notice how we worked forward with our rise over a run, rise over a run. And here we actually had to work back, coming up, in order to get that graph how we wanted to. But it still works the same way. Y equals mx plus b with our y-intercept where it crosses the y-axis. Our slope, whether it's negative or positive, slope's going to be the rise over the run. If we don't have a fraction for our slope, simply, now remember, we've already taken a fraction, put it over 1, and then it could be worked out there. Hopefully all this makes sense. You can see our springboard going from polynomials into graphing linear equations. If you have any questions, let me know. We'll be glad to help you out. Don't be afraid to try some new stuff, some problems in here. If you see something, say, I don't know if I can handle it. Give it a shot, scratch it out on paper. And I promise you this, that if you give it your best shot and work through it, even if you don't get it, you can ask for help, and just that effort of trying it yourself will make a big difference. We'll see you next class period.